Hi, my project is Infinity Math, an interactive complex dynamics laboratory designed to make fractal mathematics easier to explore and understand. Infinity Math is based on a simple repeated equation, z sub n plus 1 equals z sub n squared plus c. Even though the equation is small, repeating it many times can create incredibly detailed and complex patterns called fractals. The project uses complex numbers. A complex number has a real part and an imaginary part, so every point on the graph represents a number with two dimensions. This allows the app to turn mathematical calculations into a visual space that users can explore. This is the Mandelbrot set. In Mandelbrot mode, every pixel on the screen represents a different complex number called c. For each pixel, Infinity Math begins with z equal to 0 and repeatedly calculates z squared plus c. If the values grow beyond a magnitude of 2, the orbit is guaranteed to escape toward infinity. The colors show how quickly this escape happens. The black regions represent points that do not escape within the selected iteration limit, while the bright and detailed boundary shows where very small changes in a value can create completely different behavior. Users can scroll to zoom into the fractal, drag to pan across it, and adjust the maximum number of iterations. This makes it possible to explore the increasingly detailed boundary created by the same repeated mathematical rule. When I click on a point, Infinity Math reveals the actual calculation behind that pixel. It shows the selected complex coordinate, every value in the sequence from z0 onwards, and whether the orbit escaped, reached the iteration limit, or entered a detected repeating cycle. The app also displays the orbit on an Argand diagram. The horizontal axis represents the real part of the number, and the vertical axis represents the imaginary part. This means users can see the journey of the calculation through the complex plane instead of only seeing a list of numbers. Infinity Math also includes Julia-set mode. It uses the same equation, but instead of changing c for every pixel, it fixes one value of z and changes the starting value of c. Small changes to c can create dramatically different fractal shapes. The project also includes an educational mathematics section, which explains complex numbers, iteration, escape conditions, and the escape time algorithm. In addition, the performance lab compares rendering times for different resolutions and iteration limits. This shows the connection between the mathematics and the computer science required to render it. I used OpenAI Codex with GPT 5.6 as a development collaborator throughout this project. I used it to help turn the original idea into a structured React and TypeScript application. We started with the mathematical calculations and canvas renderer first, then built the interaction design and visual interface around them. Codex helped implement and review the complex number operations, escape time algorithm, web worker rendering, orbit inspector, Argand diagram, responsive design, and performance testing page. It also helped create automated tests for complex arithmetic, escape detection, bounded cycles, coordinate mapping, and rendered pixel buffers. I used Codex as a collaborator to speed up development, testing, and refinement, while I directed the project idea, chose the features, reviewed the work, and shaped the final experience. Infinity Math demonstrates how one simple equation can create infinite complexity, while helping people understand the connection between mathematics, algorithms, graphics, and performance. Thank you.